Again, hope you remember while finding complementary function, we considered phi of dy equal to right hand side was considered as equal to 0. Okay, now see what I'm doing. So again, let me start with the phi of dy equal to f of x. Our aim is to find y. So I'll operate on both sides. Operate on both sides. What is to be operated? 1 upon phi of d. So it is like this. 1 upon phi of d operated on phi of dy equal to 1 upon phi of d operated on the f of x. This will cancel and then we'll get the y of p 1 upon phi of d operated on f of x. So this is particular integral, right? This formula gives the particular integral. Getting everyone? Right. In between, please let me know whether you are getting it or not. Yes, Samaste Sarvana.
Yes, sir.
Yes, sir.
Okay, just 1 minute. Let me see the previous page number. Last page number, it was 15. So it is now 16. Okay. Okay, now Radha. There are 3 methods to find pi. 3 methods are there to find the particular integral, right? Okay, so now 1 shortcut method, right? Second, general method, and third, method of variation of parameters. Method of variation of parameters. Okay, गेले हे अरे यार काय झाले ठीक आहे नो प्रॉब्लेम Okay, nowadays I don't know why it is happening, but many times during the first lecture also I have seen that in between we lost the connectivity. So we want to start with the shortcut method. Huh? So let me start on the next page. So page number 17. Write down. Shortcut method. Okay, inside the write down shortcut method for exponential functions. Shortcut method for exponential functions. Okay, what is exponential function? What is exponential function? क्या होता है exponential function? बताओ. A function whose base is constant and power is function of x, right? For example, e raised to 3x exponential function, e raised to minus 5x exponential function, 5 raised to x exponential function, a raised to minus x exponential function. Okay, all these are exponential functions. Other way here. कदी है maths? This. Okay. Okay, all these are known as exponential functions. We can consider constant as exponential function, since constant is equal to constant into e raised to 0x. Right now, all these are exponential functions. Getting everyone? Samajhte sarvanna? Okay.
Yes, sir.
So let me write the question. Try to understand. Question: to find pi of phi of dy equal to e raised to x. Right, इसका हमें pi find करना है. Yes, what will be the answer? Y of p will be equal to 1 upon phi of d, na? Operated on e raised to x. That we want to understand. That we want to find. Okay. But what is phi of d? Phi of d. Let me start with this part. Phi of d operated on e raised to x equal to, what is meaning of this? What is phi of d? याद है ना आपको? अरे phi of d याद है या नहीं? A naught d raised to n plus a1 d raised to n minus 1 plus a2 d raised to n minus 2 and so on up to an, and this is to be operated on e raised to x. Let me operate. अब मैं ऑपरेट करता हूं, ठीक है? तो ऐसे ऑपरेट करेंगे. Equal to, so we started with phi of d operated on e raised to x, and now we are at this step. A naught d raised to n. I'm operating a naught d raised to n on e raised to x. E raised to x. Okay. Plus a1 d raised to n minus 1. E raised to x. Plus a2 d raised to n minus 2. E raised to x. And so on. Getting everyone now? Plus what the last term is? A n e raised to x. Right, but we know this. What we know? We know this part. What do you mean by d? D क्या होता है? अरे d डेरिवेटिव होता है. d by dx of e raised to x. और क्या होता है डेरिवेटिव? a e raised to x, है ना? What is d square? Second derivative. So what is second derivative? A square. In the same way, tell me what will be d raised to n? Yes. See, first derivative a raised to 1, second derivative a square, third derivative a cube. So a raised to n, e raised to x. आ रहा है सबको समझ में? That I am substituting here, huh? So phi of d e raised to x equal to, I'm writing it once again. So equal to, I'm writing it from here. Okay, a naught. When d raised to n operated on e raised to x, what is it? A raised to n e raised to x plus a1, then a raised to n minus 1 e raised to x, and now so on until the last term a n e raised to x. Now see what I am doing. I am writing in this way: a naught into a raised to n, a1 a raised to n minus 1, a2 a raised to n minus 2, and so on, an, and then e raised to x is taken outside. Okay, अभी इन दोनों को कंपेयर करना है. You compare these two, 1 and 2. Yes, कंपेयर करके मुझे बताइए क्या आ रहा है. See, a naught, understand ना what I am saying? A naught d raised to n. यहाँ पे क्या है? A naught a raised to n. So d is replaced by a raised to n. यहाँ पे देखो d raised to n minus 1, a raised to n minus 1. Okay. Then next term, a2 d raised to n minus 2, a2 a raised to n minus 2. So can I write like this? Equal to this is phi of d, na? So can I write phi of a? Yes, e raised to x. Getting? So you might have understood we started with phi of d e raised to x. See, we started with here. And what is the conclusion? Equal to phi of a e raised to x. आ रहा है सबको समझ में? I'll go to the next page. Can I change the page? This is the derivation of the first formula. Huh? Derivation लिखने की जरूरत नहीं है. If you want to write it, write it. If you want to leave it, there is no any problem. At the end, we want to develop a formula. For that, we are doing all these things. Can I change the page?
Yes.
Okay.
Yes, sir.
Yes, sir.
So next is page number 18. So the I'll write the previous result once again, and from there we want to find the conclusion. So it was like this: phi of d e raised to x equal to phi of a e raised to x. Okay. Now I'll operate 1 upon phi of d on both sides. This will cancel. Okay, so e raised to x is remaining. Phi of a is constant. Okay, and operating phi 1 upon phi of d means integration. So we can write constant outside whenever integration is there. In case of derivative also it is possible. I'll take this phi of a to other side. This is the formula. So in short, you might have understood we have to replace d by a. That's it. Replacing d by a. Okay, that will be sufficient. And why it is sufficient? Note, see, d of e raised to x. What is d of e raised to x? A e raised to x. D square of e raised to x. A square. Right? D means derivative. So what is third derivative? Tell me what is third derivative of a raised to x, e raised to x. A cube e raised to x. What is nth derivative? A raised to n e raised to x. So you might have observed, if I'm not able to do in this way, but if somehow if I am able to do like this, suppose I am able to cancel e raised to x on both the side. Okay, so what is remaining? D replaced by a, d square replaced by a square, d cube replaced by a cube, d raised to n replaced by a raised to n. So what is the basic term? Replacing d by a, and that is what we have done here. Getting everyone? झेपते सर्वांना?
Yes, sir.
Yes,
काय
sir.
बोलायचं ठरवलं का आज? Getting everyone na? Now,
Yes, sir.
at this moment it might not be clear what we are doing exactly. So that will be clear from the examples. So rather, examples. It will be clear from examples. All right. Find particular integral. So we are not interested in complementary function at this moment. A raised to 2x. What is particular integral? क्या होता है particular integral? We have to take this d term to other side. Right now? And what is the formula? Formula we have written here. See, this formula we have written. What we decided, replace d by a. What is a here? Coefficient of the x in exponential terms. So 2. replace d by 2. That's it. 2 square plus 3 into 2 plus 2 e raised to 2x. So how much is it? 4 plus 6, 10. So 1 upon 12. That's it. Understood? 1 upon 12 e raised to 2x is the answer. समझ लो सर्वाना? समझ में आएगा सबको?
Yes, sir.
Yes.
Yes, sir.
Okay.
Yes, sir.
So just we have to replace d by a. That will be sufficient. Okay. We'll go to the next page. Return.
Yes, sir.
Okay. Can I change the page? Page number 19. Yes, solve this. You write in this way. Yes. Replacing d by what?
-1.
Minus 1.
1.
Minus 1, absolutely. Clear?
Yes, sir.
Yes, very good. Next example.
अभी का कोई इवेंट अटेंडेंट नहीं है।
हाँ?
अभी का कोई इवेंट अटेंडेंट नहीं है ना डीपी वगैरह। एक पहले का आपने मुझे दिया है सर्टिफिकेट अटल एकेडमी का।
हाँ, वो एक है।
उसके बाद का कोई है?
एक दिन का वगैरह नहीं चलता ना?
हाँ चलेगा ना।
हाँ, एक दिन का है कोई एक।
एक है ना?
हाँ। Just 1 minute. Okay. Solve this. Fast. I'm expecting answer from everyone now. चलो solve करो इसको. Yes. What is the answer? How many people are there? 46. Okay. Yes. So write y of p equal to 1 upon d square minus 16. एक क्या आंसर आ रहा है आपको? What answer you are getting? Yes. So 0. Right now? And 1 upon 0 is infinity. Okay? And infinity should not be the answer. Okay? Always our aim in mathematics, in fact everywhere, is to find non-zero and finite answer. Right? Answer should not be 0, should not be infinity. Okay? So what is conclusion? First formula fails. Whatever first formula you written, that is wrong. Okay, and for that we are writing now second formula. Okay, so let me write it. First formula was like this: 1 upon phi of d operated on e raised to x. What it was? Replacing d by a, e raised to x. But one condition was there: phi of a, the denominator should not become 0. Right? Now, whenever denominator becomes 0, what should be done? So we'll write it. When this is known as second formula, phi of a equal to 0. Okay, then it is like this: 1 upon phi of d operated on e raised to x, that is equal to x 1 upon. Instead of phi, we have to take derivative of phi. Phi dash, dash is the derivative, and operate it on e raised to x. Right? X as it is, huh? This 1 upon phi dash of d, it is to be operated on e raised to x only. Right? Don't write like this: 1 upon phi dash of d x e raised to x. Huh? This is wrong. Okay? This is wrong. To be written in this way. Yes, write it. So whenever a denominator becomes 0, we have to use the second formula. Second formula is written now. Now can I go to the next page? Have you written both the formulas?
Yes, sir.
Yes, sir.
After application only you will understand how it is working. Can I change the page?
Yes, sir.
Yes, sir.
Now we'll go to the previous example. The example was like this. Yes, write with me. First formula fails. Right? While checking the question papers, I think it was around 2-3 years before, 2-3 years back. The student used to write that example fails. How example will fail? Arey, formula may fail. How example will fail? Right? Na? So don't write in this way, right? First formula fails. So now we have to use second formula. What is second formula? X 1 upon derivative of this term d square 2d, derivative of minus 16 0, and operate it on e raised to 4x. Again use the first formula. What is first formula? Replacing d by 4. So x 1 upon 2 into 4 e raised to 4x. So answer is x e raised to 4x divided by 8. Getting everyone? आ रहा है सबको समझ में?
Yes, sir.
Yes, sir. Yes, sir.
Very good. Can I go through the next example? चलो आगे बढ़ते हैं.
Yes, sir.
Okay, next example. D square minus 4d चलो सॉल्व करो. Do it yourself. Yes.
One upon six.
1/16.
Very good. Next. Solve this.
Upon -6.
One upon
-6 e to the power x.
first. There is no any x. You forget the x. See, first formula fails. Therefore, we have to use the second formula. What is second formula? What is second formula? It is like this. X. First, we have to write the x. And then derivative. Now again replace d by 1.
सर फिर से 0 है.
Yes, no problem. Second formula. Already x is there. One more x. First formula fails. No problem.
Sir, x to power 3 divided by 6.
Correct. That's it. Getting everyone?
Yes, sir.
Okay. Next. Few more formulas. Okay. So say See towards board and understand. I have an exponential function y equal to a raised to x. Let me take log on both sides. What I'll get? Okay. Now let me take anti-log. So log and e will cancel. So a raised to x is always equal to remember this. Similarly, what is a raised to minus x? Getting everyone? समजते सर्वांना? ओके? अरे काहीतरी बोलत जा.
Yes, sir.
Yes, sir.
Yes, sir.
काय फॉर्म्युला आहे हा? असा आहे ना? Replacing d by a. Right, now say I want to write formula for a raised to x. काय सांगा? I had replaced d by what? कशाने? अरे coefficient of x. Here we have taken coefficient of x, na? Here also we have to take the coefficient of x, log a. Getting or not? जेपते का नहीं?
Yes, sir.
Okay, so what is formula for a raised to x? Replacing d by log a, 1 upon 5 of log a. So let me write all the formulas together now. Okay. On the next page, all the formulas corresponding to exponential function I'll write together, and then we'll go through few examples. Can I change the page? काय बोलत नाही काय नाही. काय तुम्हाला करायचं ते करा जाऊ. है की नाही? Second formula.
So you slowly increase the length of this tube at some particular value d n, which will satisfy the condition of n into n. You will get some particular reading, let's say 4.0. For this particular reading, this needle will go to maximum value. Then it will after some time again
It should be d.
increase your place at a particular value, we call it d. It will get you will get another reading.
Replacing d by log a.
So similarly, you find out a in the space, b in the space, b in the space, and so on. Now what we have seen, each maximum corresponding length has a difference of lambda. So if you subtract this,
K is a constant.
if you will subtract these two readings, you will again get lambda. If you subtract these two readings, you will again get
Okay, and last formula.
difference. Theoretically, it has to be lambda. Of course, there will be some error. But theoretically, it should be lambda. So to get the best value, what you do is you take a
So if you substitute d equal to a in last formula, d will be equal to a minus a will be 0. But how many times it will be 0? R times. So r times the first formula fails, and therefore it is x raised to r divided by r factorial. These are the 6 formulas that you have to remember. Write them. Take 1 minute and try to remember them. Understood?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. We have 5 minutes. So I have to take attendance. Which is next lecture? What is next?
Kinematic.
क्या है?
Kinematic of machine है.
नहीं समझना.
Kinematic of machine.
Kinematics of motion.
हाँ, कायनेमेटिक्स ऑफ कॉम का है. अच्छा, ते कोण घेते?
गणेश सर.
कोर्सेस. अच्छा. ओके, आहे का नाही आज? ओके, ठीक. चालेल. Attendance घेतो मी. हे by tomorrow you have to remember these 6 formulas. Try to remember these 6 formulas. Attendance 1 absent. 2
Present, sir.
3 2 present, na?
Yes, sir.
3 absent. 4
sir.
5 थोडंसं fast. 5 absent. 6
Present, sir.
7
Present, sir.
8